Now, let's discuss the basic mathematical techniques and formula manipulation, direct variation, and indirect variation, practice set one. Now, let's try to discuss number one. Power is defined as work done per time. So from the statement here for number one, by the way, you may pause the video and try to answer this first. Power is equals to work per time. Which of this is true about power? Is it letter A, increasing power will require an increase in time? So letter A is wrong simply because power and time are in the inverse relationship. So meaning to say, increase in power will gonna have or would require a decrease in time. How about for letter B? The formula for power can be represented as power equals to work times time. So the equation is wrong, right? So letter B is wrong simply because this is the formula as defined from this statement. Power is defined as work done per time. Now, how about letter C? Doubling the power will require half of the time and a constant work. So since they are in uh inverse relationship, yes, it's correct. So meaning to say a double in power will require half of the time. So meaning to say, letter C, so they are inversely proportional, it is correct. Now, how about letter D? Power and work is in inverse relationship? No, because power and work is in direct relationship. Now, how about number two? Force is defined as mass times acceleration. See here, force is defined as mass times acceleration. That would now be the formula. If the force is constant and the mass is, what's this? And the mass is quadrupled, what will happen to the acceleration? So here, if the force is constant, so force is constant, we can say that force 1 is equals to force 2, and then we could have mass 1 multiplied to acceleration equals to mass 2 times acceleration 2, right? And so if the force and the mass is quadrupled, what will happen to the acceleration? So mass 1 is mass 1, and then A1, and then mass 2, mass 1 is quadrupled. So that would be 4 times the mass 1, and that would be A2. And then we could cancel out now the mass 1. Then therefore A2 is equals to A sub 1 over 4. Now, I want you to look at the answer, even though if you're not gonna do the math. Since since the mass and acceleration, they are inversely proportional. Look at this. F is equals to ma, but mass and acceleration is in inverse proportion. Therefore, increasing mass would gonna have a decrease in acceleration. So from the statement, mass is quadrupled. Therefore, they are inversely proportional. It is quarter. So even though you don't want to have any more the formula, then you can still answer this part. Even though if you don't want, you don't have this mathematical, showing this mathematical equation, then you can still answer it. Now, how about number three? Gravitational potential energy is mgh. If the mass is doubled and the height is tripled, what will happen to the new gravitational potential energy? Let's look at this part. PE is equals to mgh. So according to the equation, if the mass is doubled, 2 times mass, and then we also have the g, and then the height is also tripled. So what is our new potential energy here? So our new potential energy here is 6 mgh. And so that would be an increase in 6 times. Next, let's look at number 4. The formula for kinetic energy is defined as K equals to 1/2 mv squared. If the kinetic energy remains the same and the mass is doubled, what the velocity must be? What? So this one is quite a bit difficult, but let's try to answer this part. So we have here kinetic energy. So we have here kinetic energy 1 is equals to kinetic energy 2. And we all know that we have M1 and then M1 half M1 V1 and then 1 half M2 V2 squared and then squared. So we can simply cancel out the 1 half, right? And so we have M1 and then we have V1 squared. And according to the problem, the mass is doubled. So 2 times the M1 and we have your V2 squared. Right? So we can cancel out here the M1 and we have V1 squared is equals 2 times the V2 squared. Now, by looking here, we have V1 over 2 and then V2 is square. And then we get the square root of both sides. That would be V2 is square root of V1 square over 2. And then this can be further simplified as the V1 over root 2 is equals to V2. And so what is now the answer here? So that would be divided by root 2. Okay? Next, how about this formula? An ideal gas equation has a formula of PV is equals nRT. Assuming that the R is constant, which of this statement is false? Let's look at this. P and V are inversely proportional. P and V are inversely proportional, so this one is correct. Doubling V will double T in constant P and R. So P and then PV is equals to nRT. Now you look at double the P will double the T. So yes, right? So P and T are in direct variation, meaning to say increasing P will also increase the T, right? This one is correct. How about letter C? If P is doubled and T is half, volume remains the same. Let's try to look here. If PV and RT, so we have your V is equals to nRT over P. So say for example, we have here, if P is doubled, so we have 2 times the P1 and T is half. So NR and then 1 half of T1. Now, what will gonna happen? The volume remains the same. So no, it's wrong, right? Because the volume is gonna be 1/4, right? So the volume is gonna be 1/4. So letter C is wrong. Now, how about this one? Letter D. If PV is equals to nRT, okay? Volume is tripled in a constant N and R. So if P is doubled, volume is tripled. Now look at here, P is doubled and volume is tripled. So 3 times the P1, pressure is doubled, 2 times the P1 and 3 times the V1. And if you look here, T, that would be 6 times, right? So that would be 6 times. So meaning to say letter D is correct, right? Because the relationship between the temperature, pressure, and volume, they are all, so for the temperature relationship to pressure and volume are directly proportional, right? So in doubling the P1 and tripling the V1, we're gonna have 6 times, okay? And so for number 5, the false answer here is letter C. How about number 6? The formula for kinetic energy is 1/2 mv squared. If the mass is doubled and the velocity is doubled, what is the new kinetic energy? So let's try to look here. Kinetic energy is equals to 1/2 mv squared. If the mass is doubled and velocity is also doubled, so 2 times v and then square. So we have kinetic energy, that would be 1/2 multiplied to 2m multiplied to 4v squared. And so we're gonna have, so we try to multiply this part, right? 2 times 4 is 8 multiplied to 1/2 mv squared. Okay, and so the kinetic energy would be 8 times the original. Okay, and that ends the practice set for this topic.